Hi, today we're going to be talking about search in the Oracle database, how you can make use of the Oracle database to find content within your database, all kinds of data, but with a particular emphasis on semi-structured and unstructured data. So we'll be giving a brief introduction, then I'm going to give you an overview of search, what it is, why we need it, and how Oracle can help with that. We'll then be looking at three search solutions, situations you might want to use search within your organization, and the Oracle technologies that can help you with that, and the code necessary to do that. And we'll be looking at a couple of advanced topics in not too much detail, but we'll be covering those, and then we'll have a quick wrap up. So let me introduce myself to start with. My name is Roger Ford. I'm a product manager in Oracle. I've been working with Oracle since the days of Oracle 5. I was originally a developer building new technologies for Oracle 6, and I've worked as a support manager in technical marketing and now in product management. Okay, so overview of search. Now, here's the challenge. It's estimated that if we exclude pure binary formats like image, video, and sound, then 90% of the data on the planet is unstructured or semi-structured text. Now, maybe I should explain the difference between those two. Unstructured text is just plain text. There's no extra information other than the text itself. All semantics and meaning is within the actual text. Semi-structured text is things like HTML, JSON, and XML, where there is some form of tagging or external constraints around the data that explains some of the meaning of the text or puts the text into context. So those are the two things that we're going to be looking at, is unstructured and semi-structured text. Now, you might be saying, is this relevant to me? Well, it definitely is. Even if your company works primarily with purely numeric data or purely relational data, you will have unstructured or semi-structured text somewhere within your organization. Every company has documents to deal with. Every company has records of meetings, discussions, whatever, even just email. All people deal with text. So everybody can benefit from the ability to make best use of their unstructured text. Okay, so let's step back a bit. I joined Oracle in 1988. Some people think of that as pre-internet age. It wasn't pre-internet. We did have the internet, but at the time it was only useful for email and Usenet. So I had access to those, and they were great for what they did. And then this thing called the World Wide Web came along, and I accessed that over a telnet connection at CERN, where it was originally developed. And I have to admit, I was underwhelmed. Yes, there was data there and you could jump around in it, but there was no way to find any of that data. And the World Wide Web only really became useful when people started cataloging the data on the World Wide Web. So we started off with Yahoo and catalogs like that just listed the contents of the internet, and you could step through it looking for things that you wanted. But again, it only really took off when we started getting search engines, things like Alta Vista and Google. Suddenly people could find the data that they wanted on the internet, and there was an absolute explosion of internet usage as people started being able to find data on the World Wide Web. So we're all familiar with that. Everybody's used to using Google, Bing, whatever your favorite search engine is, and it makes the internet usable, and it means that you can find almost anything that you want on the internet. But at the same time, your company almost certainly has large amounts of textual resources in databases, in email archives, document stores, and so on. But much of this data is siloed away and cannot easily be searched. And that's what we're going to be talking about today, how we can use database search technology to make all of those textual resources currently hidden within your organization into useful data that you can access. Okay. So Oracle Text. A lot of people don't even realize that they have Oracle Text. Oracle Text is the search technology built into the Oracle database. It's been there right back to Oracle 8i, although of course we've developed it considerably since then. So if you have the Oracle database, you have Oracle Text. It's possible to install a database instance without text, but you have to go through a few steps. You have to use DBCA or a similar utility to manually install the database without Oracle Text. Otherwise, if you have the database, any version, any release, then you will have Oracle Text in it. There's no additional licensing cost. It's not an option. It's a standard part of the database. So having said that, let's move ahead and see what it can do. Now, Oracle Text can handle pretty much any kind of text. First of all, it can handle text that's actually in the database. It could be in a varchar2 column or a lob column, clob for character data, blob for binary data, or it could be held outside of the database, and there could be just some sort of link inside the database. If it's file system, it could be the file name. If it's a file on the web, then it would be the URL. And we can extract this text from those sources and index them within the database. We can deal with many different types of text. Plain text, HTML and XML all have special processors, or we can deal with binary documents. We understand some 150 different Office document formats, the obvious ones being Word, PDF, PowerPoint, and so on. And we can handle pretty much any language as well. We can handle space-separated languages, whether they're in the Latin character set or in Cyrillic or Thai character sets, for example. And we can also even handle pictogram languages such as Chinese, Japanese, and Korean. We have special processors called lexers for those pictogram languages. Okay, so now we're going to look at three simple search scenarios, ways that you would use Oracle Text, reasons that you'd want to use Oracle Text, and the code necessary to actually do that. So the first scenario we're going to look at is one that many people will have come across. You've almost certainly got data like this in your database. So the problem scenario is that we have a database of company contacts, and there are millions of company names in there in a varchar2 column. So we're talking about a fairly short piece of text, but we want to be able to search that for words within the text. So the solution to that is simply to create a search index on the company name column of the database. And that will allow us to do keyword searching for particular words within a company name. And we can, of course, as we're going to be doing this through SQL, we can combine that with any other kind of SQL search. So let's have a look at the code to do that. Now in 21C and 23C, the syntax is extremely straightforward. You'd create an index just like you would normally, specifying the index name, the table name, and the column name. The only difference is that we add this search keyword in there. So we say create search index, and in this case, company name index, on our customers table, column, company name. If you're using 19C or earlier, you need a slightly more complex syntax, and you then just say create index, the index name on customers, company name again, and then you say this special phrase index type is ctxsys.context. However you create your index using either of those two create statements, then that then creates an index in the database. May take a little while. For a few million company names, it's only going to take a few seconds. But if you've got long texts, then it might take a few minutes, maybe even a few hours if there's enough data in there. When we've created the index, we can then do a query using this contains function. So contains is a special operator within SQL. It takes the name of the column that you want to search and a search string. So here we're saying that we want to find all companies that have chemical or chemicals in their name, hence the wildcard at the end of that. You'll notice that there's no wildcard at the beginning of the term. This is not a like search, it's an index search on words. So we're searching for any word beginning with chemical. The contains operator itself returns a value which is basically either 0 for a non-match or greater than 0 for a match. So we always use it in this fashion, where contains blah blah greater than 0. So that's it. That's really straightforward to create an index. There's some customization options that you could add in there with a parameters clause, but we won't go into those at this stage. Now, okay, that's great if you just want to search a single column, but maybe you don't know exactly where the data is. Perhaps you want to search across multiple columns, maybe even multiple tables or multiple schemas. And that's where this special package DBMS search comes in. This is new in 23C. Does require 23C, although it's possible that at some point we may backport this to 19C. But this is something we call the ubiquitous search index, the ability to search over all sorts of tables, views, even schemas in the same index. So let's look. Oh, I'm sorry, I should mention that the data is indexed in JSON format, and we'll see why in a second. So move on to a better description of this scenario. So we've got an application, and the application uses multiple tables from different schemas, and we want to be able to put a search box in the top of the screen, allowing people to search across all of those tables. So the solution is going to be to create this DBMS search index, and that will index all text and numeric columns from the tables that we added. And we can use JSON features in order to drill down into the search results. We'll see that in our code screen here. So first of all, we create an index using dbms search.createIndex, and we give it a name. That will create a table with the same name, which has a search index on a column within that table. We add sources to the table by just specifying the table or view name with an optional schema name at the front. So we're adding customers, orders, and contacts to that index. Now, the table that's created, customer index, has two columns of interest. One is a metadata column, which records the original source of the data that's being indexed. And the other column is the data column. Now, this contains a virtual document constructed from all of the columns from the table in question. So we get one row in this customer index table per row of the original sources, and it stores it with this metadata column showing us the source and a data, which is virtual document. So it's not actually stored there, it's just constructed on the fly, indexed, and then thrown away. So we can do a search using the contains query as we used before, or we can use JSON text contains. Now, because data is a JSON column, as I said, it was constructed from the different columns of the original source. This allows us to search in particular tables or particular columns for our source. Here we're looking for the word Williams appearing in any column within any table. But we could use that middle parameter. Here it's $.star, meaning anything. We could use that to restrict the search to particular tables or columns. Okay, so that's DBMS search to search across multiple tables. But the third scenario, what if the data isn't actually in the database at all? Everybody's got documents on their system. Pretty much every PC in the land has Microsoft Office or some open source equivalent, and everybody generates documents, or at least receives documents from other people. So if you're like me, you've probably got hundreds of Word, PDF, PowerPoint documents on your system, and it would be useful to be able to search them. Now, we could put them all into the database. We could load them into a blob column and index them there. Oracle will understand the document formats and index them, but maybe we don't want to put them in the database. Database storage is actually relatively expensive. Let's put them on object store instead on cloud. If you're looking at an on-premise solution, then we have what are called data stores, special data stores that will allow you to access external resources. But we're not going to be looking at that now. We're going to be looking at the cloud solution, which uses a package. Actually, so I beg your pardon, this is wrong here. It's not, the cloud solution is using DBMS Cloud, not DBMS Search. And we'll see that in a moment. So here's the scenario in slightly more detail. We have a large collection of Office document files in object storage, and we need to be able to search for content keywords in that document collection. So we're going to use DBMS Cloud to create what's known as an external text index. That's a text index on external documents. Now, this is currently only available on Autonomous Database. And it has a sort of built-in crawler so that once you've created the index, you don't have to worry about maintaining it. As you add new documents to object storage, they will automatically be identified and indexed and made available for search. So let's look at the code to do that. Index creation, we call the DBMS Cloud package create external text index. Then we've got to give it a couple of bits of information telling it where to find the documents. The location URI here is the URI of the bucket on object storage that contains all of our files, and the credential is the access credentials to be able to access that object storage bucket. It may be that your bucket is public, in which case you don't need a credential. But assuming that it's secured, and you would probably want it to be secured, then you just need to provide a cloud credential to access that storage. We then give it an index name, which in this case is docs index. And it will then create a table called docs index $text IDX, as we see in the query afterwards. And that table will contain one row per document file within the object storage. Finally here, I should mention this format. That contains a couple of parameters of interest. Refresh rate is how often it should go back to object storage and look for newly added or deleted documents in our object storage bucket. So here we're setting it to 5, which means take a look every 5 minutes. Now, the second argument there is binary files true. If you don't set that, it will assume that all the documents are plain text or HTML, and it will ignore anything that it finds that are not plain text. But if we specify binary files true, then it will pass all those files through our filter, which will convert them into indexable text. So once we've created our external text index, we need to give it a minute or two to fetch all the documents and index them. And then we can use a contains query, as we did for the in database search. And we can search the object name column, which is in this case where the index is created, and we can search it for content words. And here we're doing slightly more complex search than we've seen before. We're doing a fuzzy search, and that's looking for words that sound similar to Oracle spelt with a K. So fuzzy is just one of the many operators that we provide in Oracle Text, and we will see that in slightly more detail in a second. That's our three scenarios: in database, short text, multi-table search, and object file search. Now, I'm just going to cover a couple of slightly more advanced topics, not in any detail, but this is stuff that you will want to investigate if you're doing further searching, further investigation into Oracle Text. So the contains query operators are actually pretty complex. There are many things that you can do within that contains search other than simple single word searches. So you can do Boolean searches and or not, and so on. You can use wildcards. We saw that in an example earlier. You can do stem searching for words with the same linguistic base, and many other things. I won't try and go into them in any more detail here, but if you're interested in this topic, then I would urge you to look at the Text Developers Manual in order to find out more of the capabilities of those queries. Secondly, customization. We've only looked at default indexes at the moment to do a standard out-of-the-box search, but there are many changes that you can make to an Oracle Text index to customize the way it works, the way it deals with text, and so on. And all of these stages can be modified by plugging in your own code. So you can write a new procedure, you can borrow a procedure that somebody else has written and plug that into the indexing pipeline. So once again, I don't have time to go into this in lots of detail, but I would urge you to look into the indexing pipeline capabilities. And again, this is all in the Oracle Text Developers Guide. Now, if you're interested in taking things further with Oracle Text, then I would strongly urge you to take a look at our live labs. So just go through a couple of conclusions before we talk about live labs. You have Oracle Text, you have the database, so you have Oracle Text. Oracle Text is great for adding functionality to existing applications. Multiple tables, you can use DBMS search, and files in the object storage, you can use create external text index. Now, those three scenarios that I've talked about today are really well covered in these Oracle Live Labs. So just go to Oracle Live Labs, just search for that in Google. That will get you to the Live Labs homepage. And then in the Live Labs homepage, just type Oracle Text. And these are the three live labs which cover the three topics that I looked at today. General full text topics, DBMS search, and create external text index. Okay, so that's been my presentation. Thanks for listening to it, and I hope you enjoy Cloud World. Thank you again.